In this video, what we're going to do is we're going to solve systems of linear equations with graphing. So we're going to use the techniques of graphing in order to solve systems of linear equations. Before I get into this, I just want to emphasize this. This video is not going to teach you how to graph a line. This video assumes that you already know how to graph a line. So if you need a refresher on how to graph a linear equation, then you'll have to check out my playlist on graphing linear equations. There will be a link to that in the description of this video. Now, solving a system of linear equations using techniques of graphing is a fairly simple concept. We're going to start with a system of linear equations, and then we're going to graph each linear equation or graph the solutions to each linear equation. Those solutions will be a line, and then we're going to just use our eyes and observe where the lines intersect. Like I said before, there's a lot of different ways to graph lines. You can graph using what I call the table method, or finding a bunch of points on the line and then connecting the dots. You can graph using the slope-intercept form of a line. You can also graph using technology. And for the purpose of this section, that's what we're going to do. We're going to graph using technology, and I'm going to utilize a calculator system called Desmos. So if you watched the first video, we looked at the following system of linear equations: 4x minus 7y equals 23, and y equals 3x plus 4. And we said there is a solution to this system at the point -3, -5, right where the graphs of the two lines cross. Now, how I created these lines, I created these lines using technology. And so I'm going to show you how to do that. If you go to desmos.com with a calculator, you can find this piece of technology. It's online, free technology. And you can simply just type in your equation, 4x minus 7y equals 23, and then type in your other equation into the next line, y equals 3x plus 4. And now I have two lines. Now, obviously, with the way that we've graphed here, I have to go find where the two lines intersect. Desmos is nice in that they kind of highlight that. So if you grab the screen, you can move it around a little bit. You can zoom out and zoom in. But if you put your cursor where those intersect, usually Desmos gets the point. And sure enough, where those two lines intersect is the point -3, -5. Now, if you did this by hand, you would simply by hand graph the line 4x minus 7y equals 23, and by hand graph y equals 3x plus 4, and then observe that -3, -5 is where the two lines intersect. And again, where I'm getting -3, -5 is from the x value and the y value. So as you can see, that would be a -1, -2, -3. That might be hard to see a little bit, so you can change your graph settings up there. Let me do steps of size 1. So if I go left 3 units from the origin, and then down 5 units from the origin, I would see that, yes, my point is -3, -5. So you can either use technology or graph by hand. Again, if you want a reminder of how to graph by hand, a link to how to graph lines by hand will be in those videos in the description. All right. So it's as simple as that. Graph 2 lines, see where they intersect. That point of intersection is my solution. Now, if we had to do this in another example, let's say we have the system x plus y equals 5 and y equals 2x minus 1. If I want to find the solution to that system of linear equations, then I would graph each of those lines and then see where they intersect. Let's do that using technology on this one. So we go back to Desmos, and I am going to clear out the lines that I had, and I'll recenter my grid. The two equations were x plus y equals 5 and y equals 2x minus 1. Notice that it looks like these two cross at the point 2, 3. So we went from the origin, we went right 2 units and up 3. That means the solution to this system of linear equations is 2, 3, or in other words, when x is 2 and when y is 3. So it really is that straightforward. Let's check out something else that could happen. Let's look at the equation x plus 2y equals 6 and the equation y equals -1/2 x minus 2. Let's assume that these two are the system of linear equations we want to graph and find the solution for. So these two equations make up the system. Let's graph these two individually and see where the two lines cross. Again, I'm going to use technology for that. So x plus 2y equals 6. And y equals -1/2 x minus 2. I apologize. There you go. X plus 2y equals 6. Y equals -1/2 x minus 2. What you'll notice is that these two lines, it doesn't look like connect in this zone. Now, if you scroll out, they might connect. No, they don't. So you'll notice these two lines are running parallel to each other and therefore are never going to cross. This is the case in which we have no solution. So there is no solution to this system of linear equations because when we graph the two lines, we got parallel lines. Now, the way the infinitely many solutions would work, that's the other kind of unique case, is if we had two lines right on top of each other. And you can see the green line and the red line are actually the same line in this case. In this case, if you graphed both and it turned out that they were both the exact same line, we would say there are infinitely many solutions. There we go. So, like I said, in our case, we ended up with no solutions because we had parallel lines. And that does happen sometimes. So we saw that this system had no solution because we ended up with parallel lines. Let's check out one more system. Y equals 1/2 x plus 4 and y equals negative 3x plus 1. Again, I'm going to use technology to quicken the pace of finding the solution, but you could easily graph both of these by hand using the slope-intercept method, meaning both of these are in slope-intercept form, and therefore you could graph those using the slope and the y-intercept of each. But let's check this out in terms of technology, just to make our lives a little bit quicker. The first equation was y equals 1/2 x plus 4. Oh, that graphed in purple. And the second was y equals negative 3x plus 1. All that graphed in black. By the way, you can always change on Desmos the colors that you want. So if I wanted blue and, oops, some other color, I don't know, orange, then I could get those. I think I'll use blue and red. There you go, two primary colors. Now you'll notice by just looking at this, I can tell that the point of intersection is somewhere between 0 and -1. It kind of looks like, for the x value, it kind of looks closer to -1 on the x value, and somewhere between 3 and 4 on the y value. If we zoom in a little bit and get really, really close, that's kind of a tough to see point there, isn't it? If I ask you where that is, well, it kind of looks like a little bit more than 3/4 of the way to -1 in the x value and a little over half the way to 4 in the y value, from 3 to 4 in the y value. The technology that I'm using, that's Desmos, actually will give you a decimal point. This decimal is, in this case, rounded to 3 decimal places. Now, that is not the exact point of intersection. But if you realize what 0.857 is, that's basically 6/7. And if you take 0.571, that's basically 4/7. So let me rewrite that. Oh. The solution to this one is actually the point -6/7, and then 3 and 4/7. Now that is a very hard point to actually see. If we wanted to like find the point rounded to a couple of decimal places, then obviously we could have used Desmos. But this highlights one of the issues that we have when we're trying to solve systems of linear equations. Sometimes our solution is not very easily seen, even with technology. Even with technology, it was really hard to figure out that this was -6/7 and this was 3 and 4/7. So again, that kind of highlights the difficulty around finding the point when you're graphing. Okay, so this graphing method has that as one of its drawbacks. So a system like this is pretty hard to solve with just graphing because we ended up with a point which was kind of difficult for us to see with our eyes. And though that is one of the two main issues with graphing. That is, what if the point has really tough, unrecognizable values? Like I look at it, but I can't quite see where the two lines cross. They cross at something like -6/7 and 3 and 4/7, and I can't quite tell where they're actually crossing. The other issue with graphing that you may run into is what if the point has really large values and you're trying to graph this by hand on a grid that can't go up to those really large values. So if you graphed the two lines by hand and the two lines cross, but they don't cross on the grid that you've created, how do we figure out the actual answers in those instances? So while graphing is a very nice method, especially if we're allowed to use some technology, it does have a couple of drawbacks. And therefore, in the next couple of parts, we will look at some algebraic ways to solve systems of linear equations. And those algebraic ways won't have the same drawbacks.